Actually, wait, Michael takes everything to huge question.
All right, I can't remember which ones we had done from yesterday. So we're just gonna start at the beginning and go down the list. A is the multiplicative identity. Because if you times something by 1, what happens? Nothing. You get the identical answer. Okay, that's the multiplicative identity. I'm going to skip down to D, because D is the same thing, only it's the additive identity. I can't remember, did you do those yesterday? All right, so we're good. All right. B. Now I want you to look carefully at B. What exactly is changing from the left side to the right side? Okay, he's up here going like this. They changed order. They moved. The Y and the X moved. That is commutative. What do we do when we commute? What do? We switch positions, right? From home to school or whatever. That is commutative. So problem B is commutative. You can abbreviate that word, but I want to write it all out once so you can see that's what the word looks like. Commutative, and it's multiplication. So it's the commutative property of multiplication. Now, look carefully at C, because C, nothing moves. Aren't both sides X, Y, Z? Yeah. So what changed? What's different? The parentheses. In other words, how they are grouped or how they are associated with each other. So C is the associative property. The order didn't change. Nobody moved. They got regrouped. When my mom used to tell me, I don't want you associating with that person, what she meant is don't be in their group. Stay out of their group. So associative property groups things. All right, E is the multiplicative inverse. Because inverses, the word inverse in mathematics means they cancel each other out. They're canceling each other out. F, look at it. What happened? Commutative. They look at the A and B. Didn't they move? Didn't they switch places? So that's another commutative.
And that's the exact same.
Another commutative. Whoops, not an addition, multiplication. You're allowed to abbreviate. What's happened in G? They're canceling. So this time it's addition, but they are inverses, for sure. They are inverses. Now look very carefully at problem H. What changed? What changed is what's in the parentheses, right?
Yeah.
So that's associative of addition. Yeah, the groups change. That's a good way to think about it. Groups change. All right, anybody, oh, I'm erasing these. Anybody have a question about any of those? Okay, let's look then at part 7. Did anybody get this far when you were working on your own? Did anybody get to part 7? Okay. Where's my signature? Charlie? What did you get? Which one did you get?
I got, for A, I got 27 over x to the 6th.
Okay, stop right there. Charlie got 27 over x to the 6th. Now let's look at that. Would you agree with Charlie, even if you didn't get that far, looking at it now, would you agree with that?
Yeah.
I do. I think it's good. All right, did you get another one, Charlie?
Got C and D.
You got C done?
Yeah.
All right, let's go ahead and do B since we're just kind of go in order. Anybody remember how to handle something like this?
You have to flip it.
You do. You do. Negative exponents move things. And since that negative exponent is on the entire fraction, it's going to flip the entire fraction. So when you have a fraction to a negative power, you're going to flip the fraction. And then the power just becomes positive. All right? Now we'll do what Charlie did up here. We'll just square everything. So we'll have 4y squared over 25 x squared. How does that look to everybody? Look okay? You know what I just thought of? You guys saw some people put their thumbs up. Oh, this brings back horror memories. COVID, Zoom. So you'd have your whole class and all their little faces are showing up. And you would say, okay, does everybody understand? And you'd see all these little gold thumbs ups. Did you guys do that? Thumbs up?
Yeah.
Oh, I hated that so much. I'm so glad we don't do that anymore. Just know, if we ever have to do that again, like this year, if we had to shut down and go to Zoom, I'm retiring. So you'll have a new teacher, because I'm done with Zoom forever. All right, Charlie, you got this one. What did you get when you did it?
I got 5y over 2x to the 4th.
So your final answer,
I like it,
I'm
Charlie.
gonna put it up here, 5y over, what'd you say?
2x to the 4th.
Wow, how did he do that? I don't know, I haven't done it, so I don't know if it's right or not. Let's check it. Brooklyn Bowen, what would you, did you do this already or not? No, okay, what would you do to get started? There's lots of options, so just, yeah, there are lots of options, that's not one of them. When do we cross multiply? We do cross multiply in some situations, but if you're gonna cross multiply, that has to be an equals. When it's a times, we don't cross multiply, but we can cross cancel. It gets all confusing, I understand completely. But don't cross multiply unless you have a proportion. You gotta have an equals. But you can cross cancel here. So for example, if you wanted to, you could say, oh, here's a 3 and a 6. I can cancel those. Here's a y and a y squared. I can cancel those and make this a 1. Brooklyn, are you following on? Does this make sense to you? Okay. And I'm just saying you can do this. You don't have to, but this would be an option. So x squared, x cubed. I'm going to rewrite that. So this one now is 5 over 2xy. All right, can they do anything over here? Well, that and that, and that, and that. Oh, yeah, I can cancel this y with this y. I think Charlie was right. 5y over 2x to the 4. That is not the way I would have done the problem myself, but that's okay. That's what's great about math. You can do it lots of different ways. So I don't know how Charlie did it. I don't know how you would like to do it. This is one option, and we got the answer. So anybody have a question about that? Okay, Erica, have we gotten to your question yet that you had, or did we answer it?
Yes.
Okay, next, D. Charlie, just for fun, give us your answer. What did you get for D?
X to the 8th z to the 6th over 2y to the negative 9th.
Alright, I wanna see if Charlie's right or not. Let's see if it's right.
Actually, that's not true. She's divided by two.
I know how to do the negatives.
Okay. First thing I notice is we have a 3 over a 6, so I'm gonna make that a 1/2. Is that alright with everybody?
Yeah.
Now, I'm looking at my x's, and I need to put them together. I need to combine my x's. What do I do with the negative exponent again? I move it. So this guy right here is gonna have to come to the top. So there's 5 x's sitting up there right now. I'm gonna bring 3 to the top. Does it make sense to you that I would then have 8 x's up there? This is the same thing. I got 5 in the bottom already, but I'm gonna bring down 4 more. You can't have negative exponents. So Charlie would have to do another step here. You cannot have negative exponents in that answer. So I'm gonna bring these 4 down and give you y to the 9th on the bottom. Now my z's, nothing's moving, but I got 8 of them on the top and 2 of them on the bottom, so when I start canceling, I'm gonna have 6 on the top. So Charlie, you were good, except that, I'm not sure why that was negative. Did you subtract the exponents?
Yeah.
Okay, but that would be on top. So you have y to the negative 9th on the top, which would make it y to the 9th on the bottom.
Yeah.
Good job. Anybody have a question about that? You don't need that one, I put it in there, but you don't need it. Is that okay? All right, one more of these. I'm gonna put some extra practice in Canvas today, hopefully, for you if you want to practice some exponent. 4x to the 5th, y to the negative 3rd. This is a disaster. So one option is to flip it right from the very beginning, because that's gonna happen eventually. Let me tell you my preferred option. And again, your brain probably doesn't work the way mine does, because mine's really old and tired. But I think it's easier. I know I'm going to flip at some point, but I think in a mess like this, it's easier to simplify this first and then flip it. Because keep in mind, if you flip this fraction, everything stays exactly the same, except this is now the bottom and that is now the top. Alright, so you're still gonna have a big mess. So I think I'm gonna simplify this first. Alright, so 4 over 8, I'm forgetting that. Forget that for a second. So 4 over 8, I'm gonna have a 2 down here. Now, what's gonna happen with my x's? I have 5 of them over, oh, careful, it's a positive 1 down here. So I have 5 of them on the top and 1 of them on the bottom. So think that looks like this, guys. What happens? Don't those cancel? So what are you left with? 4 on the top. Now this one's a little tricky, because the 3 will come to the bottom, but the 4 will go to the top. So it's 1 on the top. And then for the z's, these have to come down, so there's 2 down there. You're bringing down 8 more, so that's going to give you 10 on the bottom. Anybody have a question so far? We are not done. I haven't done one, so I'll take it out. still to the negative second. She flipped hers first, I'm flipping mine now, it doesn't matter, at some point you have to flip. So I'm gonna flip it, so I have 2z to the 10th over x to the 4th y, and I gotta square that. So what do I get when I square that? 4, 20, very good. Guys, I understand the properties of exponents are confusing. So if you can't remember the properties, just think about what's happening. You have z to the 10th times z to the 10th, right? So if I wrote this out, it would be z, 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 and another z, 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 z. So what would I have? 20 z's. So I have 4z to the 20th over x to the 8th y squared. You okay with that? All right, here we go. Writing scientific notation. You've all had chemistry, so you know what this is. What would scientific notation for problem 8a be? 4.2 times 10 to the 4th. Does everybody understand where that 10 to the 4th came from? We move the decimal point 4 places. Royce, are you okay? You're kind of staring at me. You
Yeah.
know this? You know this? Okay. How about the next one? 0.00016. What would that be? 1, 2, 3, 4. 1.6 times 10 to the negative 4th. Somebody said earlier today, Christopher, how do you know if the exponent's positive or negative? Just remember that big numbers have positive exponents and little numbers are going to have negative exponents every time. Okay, now this next one. I want you to do this in 2 pieces. Scientific notation is supposed to make our life easier, and it really does. So I want you to do this part first. You can use your calculator. You shouldn't need it, but if you do, it's okay. 3.6 divided by 1.2 is 3. Now let's look at the tens. Well, I have 10 to the 19th over 10 to the negative 3rd. Don't these have to go to the top? So that's going to be times 10 to the 22nd. That was easy. Let's try the next one. What are you going to do here? We'll start by multiplying 1.5 and 7.6, and I got 11.4. Now how many tens do I have? I have 10 to the 6th times 10 to the 9th, so that's going to give me 10 to the 15th. Does that bother anybody? Oh,
Wait.
it should.
Couldn't it not be 11 before?
It can't be 11 here. Jimmy, what do you remember about scientific notation?
It has to have 1 digit before the decimal.
Exactly. In other words, it has to be between 1 and 10. Okay, remember that? So this is the answer, okay? And this is what we got. But now we have to clean it up. This has to be 1.14. As Jimmy said, you can only have 1 digit in front of the decimal point. So this is what you get. You can't avoid that. This is what you get. We're going to rewrite it.
Is it 16?
Now we gotta figure out, is it 16? We moved it 1 place, so it's either gonna be 16 or 14, right? Now, I don't know how you think about this, but I'll tell you what I think about. I know that this is the right answer. So however I write it, these two have to be equal. Since I made the first part of the number smaller, to keep everything balanced, The second half of the number is gonna have to get bigger, so it is 16. Now, you may have thought about that in a different way, and I'm fine with that. I was gonna do that. But this is the answer. All right, last one in that section. Let's multiply 1.5 times 8.5 and divide by 1.2. Did you get 10.625? Everybody with me? All right, now times 10 to the what? Let's look at our tens. We have 10 to the 13th, 10 to the negative 4th, and 10 to the 7th. So these will come down. So I have 10 to the 13th over 10 to the 11th, which is going to be 10 to the 2nd.
You also just, subtract, yeah.
Yeah, absolutely. That's 10 to the 9th over 10 to the 7th. Yep. Yep. Math is beautiful. All right, is that our answer? Nope, gotta make it 1.0625 times 10 to the third. This got smaller, that's gotta get bigger. All right, last thing there, I say caution, because again, this is something that we have to be really careful about. These are not equal. Why not? Yeah, so this, the only thing that's getting squared here is the 4. So this is actually negative 16. Here, negative 4 is getting squared, so that would be positive 16. See the difference? Pay attention to that. All right, so P1 homework will be due on Tuesday, and we are now going to start P2. Remember, this is easy stuff. You know this stuff. Little vocabulary here to get us started. What do we call this? What's this called? Y-axis. What's this called? The x-axis. What's this called? The origin. And then our Cartesian coordinate plane, that's what we call this thing, is split into 4 pieces by these axes. Those 4 pieces are called quadrants, and they are numbered universally 1, 2, 3, and 4. And we use Roman numerals to identify our quadrants. Remember, this is all review stuff. We're just kind of brushing the dust off here. All right, plot and label these points. So 1, negative 1 means 1, negative 1. So I hope you put it right here and call that point A. Write 1 down 1. How about 2 comma 0? Where is 2 comma 0? On the positive x-axis. So 2 comma 0 is right here, you see. And where is C? Negative 3, negative 2. In the third quadrant. Negative 3, negative 2. So when it says plot and label, that's what it should look like. A little work with absolute value. Anybody want to take a guess at A? And then we'll move you off the island. or keep you on the island?
12.
12. What do we think about 12? Raise your hand if you think 12 is the right answer. All right, if your hand is not up, you are wrong. 12 is the right answer. Very, very good. How about B? What's the answer to B?
7.
Can you learn B?
Oh, wait.
Oh, I was on C.
B.
1.
I hear some ones. What do you think about that? I think you're right. I think you're right. Everything's inside. So we got an order of operations. Those lines are like parentheses. And remember, in order of operations, you do parentheses first. So do what's inside first. -3 plus 4 is 1, and the absolute value of 1 is 1. How about C? I heard a 0. What do you think about 0? I think you guys are on fire. Good job. Probably literally, 0. And then what about D? What about D?
4, 5.
4, 5? I don't think so. That's not a multiplication problem. So, no. So here's what I want you to think about this for a minute. Don't get confused. What if we had the absolute value of 7 minus 6? What is the absolute value of 7 minus 6? Isn't that 1? And isn't that the same as 7 minus 6? Okay, but what if it were 6 minus 7? That is not the same as 6 minus 7, but it is the same as 7 minus 6, isn't it?
Yes.
They can't process that. This is -1, the absolute value is +1. So when we take it out of the absolute value, we have to have the big one first. So it's positive, all right? So let's look at our problem. What's pi? Okay, so which one's bigger? 4. So if you did that subtraction, it would be negative, right? The answer is 4 minus 1.
Okay.
Listen. What's this one? So P1 due Tuesday, right? Tuesday.
We'll still have class on Monday. This schedule is so.
So we're taking the same as you.
I like it when everything
Yeah,
works.
sure.
Now it's
Yeah, you're talking guys, why not to go to your own school?
All right, have a great day, you guys.